Okay, guys, it's time to talk about the next chapter, chapter 5, which is the periodic law. And it starts out with a bit of history on the periodic table. So, Mendeleev was one of the first scientists to even propose a periodic table. There were actually two gentlemen that proposed it at the same time, and Mendeleev actually got it into print or into scientific journals first, so he is credited with the discovery. Mendeleev, however, how did he decide to arrange the periodic table? Well, he took all the information known at the time about all the elements, including some new atomic masses, and he put it on cards. He was a big card player, so then he started trying to arrange them in some way that made sense. And what he found was that if they were arranged by atomic mass, he found some repeating patterns. And what are those patterns? Well, if we find on our periodic table lithium, sodium, potassium, rubidium, cesium, all of these have very similar properties, which was interesting. And beryllium, magnesium, zinc, all of these had similar properties. He was also able to say it looks like something is missing right here between, calcium and the next element. He also thought that some of the periodic masses were wrong, that some atomic masses were not correctly determined. So he proposed that some atomic masses were incorrect and that some elements were indeed missing from the periodic table. And his information held up for about 40 years. So the first revision of his periodic table came by Moseley, and he arranged the atoms by atomic number. He looked at the data generated by Ernest Rutherford, and he said, well, it actually works out better if we arrange these by atomic mass or atomic number rather than atomic mass, which led to our modern understanding of periodic law, which states that the chemical and physical properties of elements are a periodic function of their atomic numbers. And periodic just means repeating pattern. So, pretty easy to understand. Modern periodic table. There were several groups not found on Mendeleev's table. One of those was the noble gases. I'm sure you may not have noticed, but we didn't have any of the atomic or any of the noble gases, and they weren't discovered until the late 1800s, and they escaped our notice or did not get detected because they have absolutely no chemical reactivity at the time. We can now make them react, certain ones at very high temperatures and pressures, but for the most part, they're just unreactive, and so it's very difficult to detect them at that time. The next group to be discovered were the lanthanides. And lanthanides, there are 14 elements in both the lanthanides and the actinides, and the lanthanides go from element 58, which is cerium, through element 71. And you'll notice on some periodic tables that they include lanthanum, but lanthanum is actually not a lanthanide, it's actually in the D block, so that's interesting. A lot of periodic tables have 15 elements listed there when there really should only be 14. And again, these are very similar in chemical and physical properties, so instead of putting them in groups by atomic number in columns, they actually do it by the row on the periodic table. And these were very difficult to identify because it was very difficult to separate them from mixtures because they're often found together, and if they have similar chemical and physical properties, it was very difficult to separate them. Next we have the actinides, and the actinides on your modern periodic table, again, doesn't actually include actinium. It actually goes from thorium, element 90, through element 103, which is lawrencium. And it is also an F block element. Both lanthanides and actinides are F block elements. Again, they have very similar chemical properties, and only through uranium, so thorium, protactinium, and uranium are the only three naturally occurring actinides. The rest, you'll notice on your periodic table, have their molecular weight or their atomic mass written in a bracket. That means that they are man-made or synthetic. So, periodicity. What is periodicity? Well, it means it just recurs at a given interval for the main group elements. Every 8 elements, they would be similar. D block elements are similar to each other, and so I think that about covers it for this section. Oh, except you will be having a lab to design your own periodic table, and I will give you information that you will put on cards just like Mendeleev, but you will not be allowed to use the internet or any other resources to try and design your periodic table. The goal of this experiment is not for you to correctly create a periodic table, but just to understand the difficulty involved. So, with that in mind, we will get ready to talk about lab. Thanks.